Welcome back to Best Academy TV. In this video, we're gonna focus on the second shape for moment of inertia. Please write moment of inertia for sphere. Most times, it's always confusing to understand the moment of inertia for different shape, but there's a shortcut rule here to know moment of inertia depending on the shape. Okay, now in terms of sphere here, we have to take the first second letter, that is S and P. The first letter here will be at numerator. The second letter here, that is the first letter here, S, we'll replace it at numerator part. The second letter here, P, will be at denominator. Please take note. And we'll repeat the M arrow square, which is moment of inertia for a circle. Okay, so let's try to know what is the first letter here. This first letter is S. When you represent S in terms of number, S is the same as 2 over. This second letter here is P. P as a number is called pentagon, and pentagon is 5. So this will be M arrow square. Please take note. So class, this is the moment of inertia for sphere. Okay, it means that if you are given mass and you are given radius or diameter, you can easily replace the values and solve for the moment of inertia for a sphere. Please take note. So let's consider the next shape so we can solve a equation. Know the formula for moment of inertia for rod. We have to take the first letter R. Please take note. Class, if you break down the letter R here into 2, I will have something like this. So remember, the first part here will be the numerator part. The second part here will be denominator part, and you repeat N arrow square. Please take note. So at this point here, what if you break this guy here, I will have something like this. It will look like this: 1, 2. Please take note. That's 1 and 2. So class, the first one here is 1 over the total of this number here. That is, if you take the total of that number, it will be 1 and 2. That is 1, 2, which is M arrow square. So this is the moment of inertia for rod. Please take note of this. Okay, so let's consider the next shape. The next shape is disc. Please write. Let's consider the moment of inertia for a disc. So for a disc here, let's write this DISC, and we know that the first letter here will represent the numerator part. The second will represent denominator. You repeat N arrow square. Please take note of this. So, but in terms of disc here, the D here represent divert. That is, divert the letter to 1s. So I will have this to be equal to the letter we consider here will be 1s. 1 here is 1 in terms of number. S represent 2. Repeat M arrow square. So class, this is the moment of inertia for disc. Please take note. So the next thing here is to solve questions on them. Okay, that means if I'm giving the mass, I'm giving radius, and you're asked to find the moment of inertia for disc, all you have to do is to write down the formula and replace the parameters. Okay, so let's solve a question here to understand this perfectly. Example 1, please. All right, let's solve this question here, class. And they said a flywheel is a uniform disc of mass 72 kg and radius 50 cm. Calculate A, moment of inertia, B, kinetic energy when it is rotating at 70 rpm. So let's solve this question here, class. We say solution. The first we are asked to calculate here is the moment of inertia. But for us to calculate the moment of inertia for a rotational motion, is to know the shape. All right. Now let's know the shape here. The shape here is disk, and we see that the moment of inertia for a disk is this, that is I is equal to class 1 over 2 m arrow squared. So our mass here is given to us as, the mass here is given to us as 72 kg. The radius is given to us as 50 cm. Converting to meter, I will divide this by 100, which I will have 0.5 meters. Please take note. So class, replacing your values here, the moment of inertia here will be equal to class 1 over 2 times 72 times 0.5 all squared. So let's replace this class. I will have this to be 1 over 2 times 72 times 0.5 all square will give us 0.25. So class, when you point your calculator, that is 0.25 times 72 times 1 divided by 2, I will have the answer to be 9. The unit to be kg meter squared. Please take note of this, okay? Now, if you look into the question, if you read the question again, we are not only asked to find the moment of inertia, we are also asked to find the kinetic energy. So class, from the expression for linear, remember from linear, we can easily represent the rotational kinetic energy, okay? If equation is on rotational, to calculate the kinetic energy, we use rotational kinetic energy. From linear, we see that kinetic energy is equal to 1 over 2 mv squared. So in terms of rotational kinetic energy, we can easily replace this as 1 over 2. The number is constant. So this is a letter here. So this letter will change. There is this letter here represents mass, and the letter for mass in rotational is moment of inertia. This letter here V represents velocity. The letter for velocity in rotational is angular velocity, which is omega, and this is squared. I will square this. So it means that the formula for kinetic energy for rotational body is this here. Please take note. So what does it mean here? It means that this I here is representing moment of inertia, and omega is representing angular velocity. So this moment of inertia depends on the shape mentioned in that equation. Please take note. This moment of inertia here depends on the shape mentioned in that equation, okay? So we have calculated for the moment of inertia, and our omega is given to us as 70 arrow pm. The word arrow pm means ref per minute. Please take note. So the omega here is given to us as, let's take note, the omega here is given to us as 70 arrow pm. That is the same as 70 ref per minute. But in physics, angular velocity is not measured in ref per minute. The standard unit for angular velocity is measured in rad per seconds. Please take note. So class, converting this 70 ref per minute to rad per seconds, we have to know the standard relationship between ref and rad, and we have to also know the standard relationship between minutes and seconds. So the standard relationship between ref and rad is this, that 360 degree is equal to 2 pi rad. Please take note. Please understand is that pi in an angle is 180. When you are replacing pi as an angle is 180. But when you are replacing pi as a number, or a number is 3.142. But whenever pi is standing as an angle is 180. So 180 times these two here will give us back this guy here. So 360 degree is the same as 2 pi rad in terms of rad. And 360 is the same as angle in a circle. Angle in a circle. So it means that this is the same as one revolution, that's one circle, which is 360, is equal to class 2 pi rad. Class, the relationship between revolution and rad is this. That is the standard relationship between revolution and rad is this. So now let's know the standard relationship between minutes and seconds. Let's know the standard relationship between minutes and seconds. So the relationship between minutes and seconds is this, that 60 seconds is equal to 1 minute. Please take note. So class, this is the standard relationship between minutes and seconds. So now let's replace it here. Let's replace it here. To convert this, that is to convert 70 ref per minute, we can easily write this to be 70 times 1 ref over 1 minute. Please take note of this. If I have something like this, 2s is the same as 2 times 1s. But there is something like 1s in mathematics. Please take note. The same thing here, if I have something like the 7 ref, is the same thing as 70 times 1 ref over 1 minute. Please take note. So let's represent our values here, class. 1 ref is 2 pi. So this will be 70 times 2 pi in rad over 1 minute in seconds is 60. So class, I will have this to be, when you punch your calculator, I will have this to be 7.3313 in rad per seconds. Please remember, we represent this pi here as 3.142, okay? So replacing the value here to calculate the rotational kinetic energy, replacing the value here to calculate rotational kinetic energy, we have our answer to be, that is rotational kinetic energy, which is equal to class 1/2 of I omega squared. So when you replace there, we have 1/2 times 9 times 7.3313 squared. When you square this, we'll have this to be class 9 times 53.7480 over 2, and the final answer here will be 241.866. So our rotational kinetic energy here will be equal to class, when you represent this here in standard form, I will have this to be class 2.4187 times 10 raised to the power of 2 in joules. So this is my rotational kinetic energy. This is my rotational kinetic energy. To get more on this topic, all you have to do is to hit the subscribe button, okay? Thank you.